Hey guys, I'm going to go through the 6.5 homework. This is solving equations with rational expressions. This first page is going to focus on a method of cross multiplication, and the method of cross multiplication only works if there's one if there's only one rational expression on each side of the equation. So you'll notice a difference between the ones up here and the ones over here, where we have two rational expressions on one side of the equation. So 1, 2, 1, 2, 1, 2. And so cross multiplication again works with when you just have one on each side. But essentially, pretty easy to do this right here. So given that you have an equation, the idea is that you can multiply. Now this isn't addition or subtraction, so we kind of got to reset our thinking because we're not adding or subtracting. So it's not like where I can't cancel things out across because it's a multiplication. I also don't just go ahead and multiply the top over here or the bottom over here to multiply the top. I don't need to do stuff like that because I'm not trying to add. So very different idea whenever you have an equation right here. Essentially what I want to do is I want to multiply both sides, let's say by 2x. So multiply both sides by 2x. Well, the reason I'd want to do that is because it would get rid of the 2x over here. So if I multiply the top here by 2x, I have to multiply the top over here by 2x. But because on this side right here, there's already a factor of 2x on the denominator, that means when I multiply the top by 2x, it's actually just going to cancel. And then I just have this being multiplied by 2x. Now, the same thing goes with this x plus 6. If I multiply the left side by x plus 6, well, I also have to multiply the top by x plus 6 over here. The difference is that on this side right here, the x plus 6 will cancel. So essentially the idea of cross multiplication is doing that, but quicker, because essentially all I need to do then is multiply this by 2x, right? Multiply the top right by 2x, and multiply the top left by x plus 6. So that's why it gets this. This is called the method of cross multiplication, and that's why it gets that name. You're not actually just multiplying straight across. That's just the way that people think about it. What you're really doing is multiplying. You're pretty much multiplying both sides. I'm really multiplying both sides by the denominators, 2x and x plus 6. And I'm multiplying this side by 2x and x plus 6. What you do to one side, you have to do to the other side. The thing is that when I do that, those will cancel from the left side, and on the right side, those will cancel. So I'm multiplying the left side, top, by what's on the bottom right denominator, and I'm multiplying the top right side with what the bottom left denominator is. So that's where it gets its name from, cross multiplication. So, but you're not actually just multiplying diagonally across. That's not really what's happening, but that's how it gets its name. So 4 times by x plus 6, and then equals, you still need the equal sign right here, equals 5 times by 2x. I can distribute the 4 here, and I'm going to get 4x plus 24 equal to 10x. And now I have a linear equation, which means I can just solve for x. So minus 4x and minus 4x. I get 24 is equal to 6x. Divide by 6, and I get that x is equal to 4. Now you might want to check and make sure that you can still plug this back into the original equation. You want to make sure that you don't get 0 in your denominator, so we wouldn't, but it looks like x equals 4 is a solution. Alright, so same thing here. I'm going to take 9, I'm going to multiply it by x plus 2 equal to 4 times by 3x. I get 9x plus 18 equal to 12x. Subtract 9x, subtract 9x. I get 18 is equal to 3x, divide by 3, divide by 3, and x is equal to 6. Moving on to 3, so I'm going to look at the top left numerator. I'll multiply it by x plus 1, which is the bottom right denominator. Take 9 times by x minus 1. I'll distribute to get 6x plus 6, and I'll distribute to get 9x minus 9. Again, I get a linear equation, so solve for x. So I get 6 is equal to 3x minus 9. I'll add 9. I'll get 15 is equal to 3x, divide by 3, divide by 3, and get that x is equal to 5. Here, 8 times by x minus 1 equal to 2, times by 3x minus 2. I'll distribute to get 8x minus 8 equal to 6x minus 4. In this step, I'm just going to do 2 moves, so I'll subtract 6x right here, and I'm also going to add 8 right there. So altogether, I'll have 2x on this side, and altogether, I'll have 4 on this side. And I'll divide by 2, and get x is equal to 2. Okay, and then I'll do x times by x minus 1 equal to x minus 5 times by 2x plus 7. Now in this case right here, when I distribute, I get x squared minus x, and then I'll have to FOIL this side. I'll get 2x squared when I multiply that together. I'll get positive 7x, so plus 7x, and then minus 10x for a total of negative 3x, and then I'll get minus 35. So now I don't have a linear equation now, I have a quadratic equation, which means I am going to get everything onto one side. So I'm going to, since the x squared is greater over here, I have more x squared over here, I'm going to subtract x squared, and I'm going to add x over here. So I'll get 0 is equal to x squared minus 2x minus 35. Now I'm going to need, now it's quadratic, so we're going to solve by trying to find two numbers that multiply to be negative 35 and add to be negative 2. If it can, let's see, so we're going to start with x and x. So I think just 7 and 5 should work. So if I do minus 7 and add 5, I think that should do it. And now I can say that with the zero product property, I can say that x is equal to 7 and x is equal to negative 5. And you might want to check to make sure that you don't get 0 in the denominator. So if I plug in negative 5, that's not going to be 0. That's not going to be 0. If I plug in 7, neither of those are going to be 0. So I think we can say that we have two solutions. I mean, we might even want to check to make sure that, well, let's go ahead and do that. So if we plug in 7, we get 7 over 14, 14 plus 7, that's going to be 21, which is 1/3, equal to, if I plug in 7 here, 7 minus 5, it's going to be 2. If I plug in 7 here, I'm going to get 6, which is also equal to 1/3. So it looks like x equals 7 checks out. Let's see if negative 5 does. So negative 5 over negative 10 plus 7, so negative 3, so 5/3. If I plug in negative 5 right here, I'm going to get negative 10. And if I plug in negative 5 here, I'm going to get over negative 6, which is also equal to positive 5/3. So both solutions check out. All right, in this case, x squared minus 3 is going to be multiplied by 2. X minus 3 is going to be multiplied by x plus 2. I'm going to distribute the 2 and FOIL this part right here. So x squared minus x minus 6. Again, I have a quadratic. I see that x squared is greater over here, so I'll go ahead and move terms over there. So minus x squared plus x plus x, there's no other x over here, and then plus 6 and plus 6. So I'm going to get x squared plus x plus 0, and that will be equal to 0. In this case, I don't have to worry about the constant at the end, which means I can just take out a greatest common factor of x, and I'll get x plus 1, which means that x equals 0 and x equals -1. And I think that should do it for the solutions. I'm not going to check. I hope they're both right, but they should be. All right, yeah, we're good. Okay, now onto this side right here where we're going to solve each equation by using the lowest common denominator. The lowest common denominator is the it's like pretty much the largest or the smallest product of all the denominators. So you can't do a cross multiplication here. So say that this is 2 over 1. You can't do a cross multiplication here because we have a third term out here. So one thing that you could do is that you could actually add these terms, so use the properties of addition that we learned from last time, and you can make this into one term. Then you can use a cross multiplication. But I don't care to do that. It's just more steps. So I use the lowest common denominator method whenever I'm dealing with when I'm dealing with one or more additional terms with rational expressions. But so the lowest common denominator, there's a rule whenever I solve. There's a rule for for solving equations. If I decide to multiply this equation by 2, I can do so if I multiply every term by 2. If I decide to multiply everything in this equation by x, I can do so long as I multiply every term by x. Now, if you're smart about it, and you decide to multiply every term by a polynomial or by something that will get rid of your denominators, that would be the ideal. So all I need to do here is multiply every term by the lowest common denominator, which is 2x. The reason why 2x is the lowest common denominator is because it's the least greatest product of all the denominators, so 2 and x, without having to use multiple terms of the product. So I'll kind of explain that. I'm sure that there's going to be more examples, like especially 10, but it's the least common denominator. You don't just go ahead and multiply everything by each denominator, by every denominator, because there could be double of you could be multiplying by the same factor, or there could be denominators that have common factors, and in that case you want to be smart about how you do this. But in any case, so if I multiply every term by 2x, so if I multiply this term by 2x, the 2's would cancel because you'd be multiplying the numerator by 2, allowing you to cancel out the 2's. And then the x would actually be remaining. So whenever I multiply 3/2 by 2x, I'm really just multiplying 3 by x, because the 2's cancel and the x and the 3 remain. So now I don't have a denominator other than 1, but yeah, so I got rid of my denominator there. This term right here, when I multiply 1 by 2x, well, there's already an x in the denominator, meaning that I have a common factor of x, so I'm really just multiplying the 2 and the 1 together to get 2. And then when I multiply these together, well, since this just has a denominator of 1, then 2 and 2x would just multiply to be 4x. But what we've just done by multiplying every term by the least common denominator is I've gotten rid of denominators. And now I can treat this like a linear expression, kind of just like what we did up here. So now I just solve for x. I'm going to subtract 3x. I get 2 is equal to x, and there you go. Alright, same thing here. Now, you can't get too confused about what my factors are. This is x minus 4, and x minus 4 stays x minus 4. This is x, and this stays x. So, and this has a denominator of 1. So, the least common denominator will be x minus 4 times by x. So if I multiply everything by x and x minus 4. Well, if I multiply this term right here by x and x minus 4, because there's already x minus 4 in the denominator, they would cancel out. So I just have to multiply the x by the x minus 3. Now, when I multiply this term by the least common denominator, because the denominator doesn't have either of these factors, then I'm multiplying 4 by both of these factors. Equal to, and when I multiply this term by x and x minus 4, because there's already x in the denominator, those would cancel. So that means 3x multiplies by x minus 4. And now I have no denominators. Let's go ahead and simplify. So I'm going to distribute the x here to get x squared minus 3x. And then plus 4x squared minus 16x equal to 3x squared minus 12x. Now I have a quadratic equation because I have powers of degree 2. Let's go ahead and get everything onto one side. So because I have 5x squared over here, I'm going to subtract 3x squared. So on the left side, I'm going to get 2x squared. And then I have a minus 3x and a minus 16x for a total of negative 19x. And I'm going to add 12x and add 12x to give me negative 7x. And I don't have any constants. So that makes it easier because now I just have to factor out the greatest common factor here, which would just be x. And I'd get 2x minus 7 is equal to 0. So now I can take each of those factors and I can go ahead and solve for x. So I'll get that x is equal to 0. Now for this one, if you want, you can just say 2x minus 7 is equal to 0. And then you can go ahead and solve for x. So you can add 7. So you get 2x is equal to 7, divide by 2, and get x is equal to 7 halves. And there you go. That should be our two solutions there. Alright, so trying this one right here, very similar. So this is x minus 1, and it cannot change from x minus 1. It will stay x minus 1, same as x minus 4. So there's no changing these factors through addition or subtraction. That means the least common denominator is going to be the product of those two. So x plus 4 and x minus 1. So when I multiply this term, the x plus 4's cancel, so I'll get 6x times by x minus 1 plus 4. Now because this has no denominators, nothing's going to cancel, so I just have to multiply it by all of that right there. And then I have 2x plus 2, and then I'll multiply that by x minus 4, since when I multiply it here, the x minus 1's will cancel. Now I'll go through and distribute. I'll get 6x squared minus 6x. And then, let's see. So I have to FOIL this right here. So that's going to become x squared, but then I also have to multiply by 4. So plus 4x squared. And then minus x plus 4x, which would be 3x times by 4. So that's going to be plus 12x. And then negative 4 times by 4, which is going to be minus 16. And then I'll get 2x squared, 8x, and 2x for a total of 10x, and then plus 8. Alright, so now solving the quadratic, I have 6x squared and 4x squared and 2x squared. So if I have 10x squared over here, subtract 2x squared, I'll get 8x squared over here. I have negative 6x and negative 6x and positive 12x for a total of 6x. And over here I have 10, so if I minus 10x, I'm going to get negative 4x. And then I have negative 16, positive 8, so minus 8, and I'll get negative 24 equal to 0. Oh, man. Negative 6x. That's going to be positive 6x. All right. I can factor out an 8 from here. No, I can only factor out a 4. And I'll get 4x squared minus 2x. Wait a minute. I can only factor out a 4. So minus x. And then minus 6. And that's all equal to 0. Let's see if we can factor this. If not, we might have to use the quadratic formula. So we have to take negative 24, and then what multiplies to be negative 24 and add to be negative 1. So 124, 2, 12, 3, and 8, 4, and 6. There isn't anything, so you have to use the quadratic formula. Darn it. So just using this right here, so we can say that a is equal to 4, b is equal to negative 1, c is equal to negative 6. So we'll get x is equal to 1 plus or minus the square root of 1 minus 4 times by a times by c, all over 2 times by 4. So 1 plus or minus the square root. And then if we do 1 minus 4 times by 4 times by negative 6, we get 97 all over 8. And let me go ahead and double check this in my calculators. So 1 minus 4 times by 4 times by negative 6. So if I do 1 plus the square root of 97, divide that by 8. I'm going to check and see if that answer works. So I have 6x divided by x plus 4 plus 4. And then if I do 2x plus 2 divided by x minus 1. Uh-oh. I did not get the same thing. Let me double check my work here. So multiply here, x plus 4 cancels, and I get 6x, so that's going to be, okay, so 6x times by x minus 1, 4 times by x plus 4, and x minus 1, 2x times by x plus 4. That becomes 6x squared minus 6x. That becomes 4x squared. And then negative x, so positive 3x times by 4, positive 12x. And then 4, negative 4 times by 4 is negative 16. And then I get 2x squared. I get 8x plus 10x. 8x plus 2x for 10x. And then I get positive 8. And then I have negative 6x squared, positive 4x squared for 10x squared minus 2x squared for 8x. So positive 6x minus 10 for negative 4, and then negative 16 plus 8, and I minus 8 minus 8, and I get negative 24. I can factor out the 4. And, there we go. That's my mistake. That's supposed to be 2. 2. Okay, that's going to change that right there, that right there. Negative b plus or minus square root of b squared minus 4 times by 2. Okay, there we go. Let's go ahead and check this again. So this is going to be 1 plus or minus. We're going to do 1 minus 4 times by 2 times by negative 6. And then, so that's going to be that's going to be the square root of 49 over 4, so that's going to be 1 plus or minus 7 over 4. Wait a minute. Oh, that's factorable then. Oh my gosh, whatever. That's factorable now, because this is going to be 8 divided by 4, so I'll get x is equal to 2, and then I'll get 1 minus 7 for negative 6 over 4, so x will be equal to negative 3 halves. So there you go, and then if you factor it, you'll get those solutions too. Okay, so that one took longer for that mistake right there. All right, now for 10, you got to be careful with this one right here, because what you don't want to do is multiply everything by x squared minus 3x times by x minus 3 times by x, because this is not the least common denominator. The least common denominator is actually just this part right here, because x squared minus 3x contains these factors right here. So if you were to factor this denominator right here, you can factor out an x and you'll get x minus 3, which means my least common denominator is x and x minus 3. So this is what I was talking about earlier, is that you don't want to multiply by two of the same factors if it's already in the other. So you're just going to multiply everything by x and x minus 3. And that will get rid of all your denominators. So when I multiply this term by the least common denominator, actually everything cancels. So you're just going to be left with 18. Okay, and then minus 6 times by x, because the x minus 3's will cancel, and then equal to 5 times by x minus 3. And now we just have a linear equation. So we have 18 minus 6x equal to 5x minus 15. I'm going to go ahead and add 6x over here. I'll get 18 is equal to 11x. And then I'm also going to add 15 and add 15. And 18 and 15 equals 33. So that's going to become 33, which means that x will be equal to 3. Now, this is where you're going to want to check your answer, because if you plug in 3 right here, you get 3 minus 3, which is undefined. So there's actually no solution here. No solution. Okay, for 11, go ahead and we're going to multiply everything by x and x plus 6. We'll have x plus 1 times by x plus 1 times by x plus 6 equal to 2x plus 1 times by x. So when I distribute, I'll get x squared plus x plus 6 equal to 2x squared plus x. So I have x squared, 2x squared, so I'll move things over to this side right here. So I'm going to get x squared here. I have 2x right here and x right here, so I'm going to subtract 2x, and I'll get minus x minus 6, and that's going to equal 0. And then this is factorable, I think, to be x. So x minus 3 and x plus 2. Yep, so x will be equal to 3 and negative 2, and both those will work right there. All right, and last but not least, we're going to multiply everything by x and x plus 3. So we'll get 5 times by x plus 3 minus 2 times by x plus 3 equal to 2 times by x. And then we'll get 5x plus 15. We'll get minus 2x squared minus 6x equal to 2x. And then I'm going to move, I don't know, I have a negative 2x squared here, 5x, negative 6x, so that's going to be minus x plus 15 equal to 2x. Let's go ahead and subtract the 2x. So I'm going to get negative 2x squared minus 3x plus 15 equal to 0. I don't want this negative, so I can go ahead and divide everything by negative to get 2x squared plus 3x minus 15 still equal to 0. I'm going to get rid of all this right here. So I have more room. And then, let's see, negative 30, what multiplies to be negative 30 and adds to be 3. So you got 1 and 30, you got 2 and 15. It's not divisible by 4, it's all 3 and 10. 5 and 6. So this one, we have to use the quadratic formula. Hoping that I have all my numbers right. So x will be equal to negative 3 plus or minus the square root of 9 minus 4 times by a times by c all over 4. So that's going to be equal to negative 3 plus or minus, so 9 minus 4 times by 2 times by negative 15. So square root of 129 all over 4. Let's see if this actually works at my calculator. So plus the square root of 129 divided by 4. And let me check my answer. Keep clicking the wrong button. Okay, and then we'll do 5 divided by x minus 2. And then we'll do 2 divided by x plus 3. And I did get the same answer whenever I added, and I'm going to assume it will be the same when I subtract. So there you go. You can keep your answer like that. All right, and that should cover 6.5.